Hey guys, welcome to PCM is no Rata. Today you're watching this video on forces by Sonal Gupta. When you look at this picture, what is the boy doing here? Here he's trying to pull the car as it is stuck in the snow, and in this picture he's trying to push the car again because it's stuck in the snow. So like this, we observe a lot of things in our everyday life where we have to put in some effort to put a stationary object into motion or to stop a moving object. And generally we experience that, generally we apply a muscular force. And so we can say that we either push something or pull something or hit something. So whatever you're doing, all these things, what will you call them? Since we're going to learn about forces in this chapter, so let's ponder about what is a force. What is it? In fact, no one has seen it, no one has tasted it, no one has felt a force. So how can you talk about force? See, when we say this is a ball lying at the rest, you kick it, it starts rolling and comes here. So you kick or you push something to move. Or something is lying here, there's a table and you want to take it, drag it to this place. So you pull it. Right now you pulled it. So every time you feel you're applying a push or a pull, they tend to change the state of rest or of motion of a body. These things will change the speed, they can change the direction. Like if something is moving here and you apply force towards right, it starts going towards right, so you change the direction. And if you have something which is compressible and you press it in the middle, you will turn it into a flower like this. So you can change the dimensions of a body, the shape of a body. So all these things, all these effects which are brought about by an external agent, which is called the force. So we would define force is an external agent which changes or tends to change the state of rest or of motion, speed, direction and shape of a body. So when I say the state of rest means something lying at rest, you have to push it to change its state of rest. Maybe you want to set it into motion, and sometimes it will be set into motion, sometimes it will not. So we say it changes or tends to change. Then something is moving, you push it, its velocity increases, you pull it, its velocity decreases. So in any case you are changing the speed of the object. And then the direction, suppose you turning something round and round and round, so you're changing the direction continuously. And anything which is compressible or even maybe brittle, you can break it with a force, so you change the shape of a body. And another important thing about force is that it has a magnitude and direction both. So it is a vector quantity, because alone magnitude doesn't decide the force, it's the magnitude and the direction together which give us the total force acting on a body. Now forces can mainly be categorized as contact forces and non-contact forces, and as the name suggests, contact forces are the forces which need a contact between the two objects. Contact forces cannot act from a distance, and the two main examples of contact forces are, one is a muscular force and the other is a frictional force. Now muscular force, when you use your muscles, of course you touch something, you pick something, you push something, only then you're using your muscular force. So a force which is exerted by muscles is actually called the muscular force, and whether you push or you pull something, right? So here we can see a woman is carrying her luggage, so she's pulling it, and here a boy is trying to hold the weights, he's again applying muscles in his body, and the horse is trying to pull the cart, he's also applying his muscles to pull. So both the push and pull, they involve the action of muscles in a body, and so that means they are under the muscular force, and you cannot apply muscular force without a contact. So it is a contact force. And the other one, the force of friction, because this always comes into action when there is a physical contact between the two surfaces. So you see a ball rolling here, so it's rolling on this surface, and wherever it goes, there is always a contact between the ball, whichever surface is down, and the ground, the floor, and then this force of friction acts, which is in the opposite direction because it always slows it down. So there is always a contact between the two forces, and that gives rise to friction. So again, friction is a contact force. The next one is non-contact forces. Now the forces, as the name suggests, that come into play without the actual physical contact between the two objects is known as a non-contact force. It means non-contact forces between two objects also act from a distance without touching each other. And can you think of any non-contact forces? I'm sure you can. You might have tried it many times when you rub a comb with your hair and or a scale with your hair, it starts extracting those small bits of paper. So these are, here we'll see a charged body interact with the other body, whether it's charged or uncharged. They experience a force of attraction or repulsion, which is called the electrostatic force. So electrostatic force acts from a distance, hence it's a non-contact force. Similarly, I'm sure you must have played with the magnets. You can see that the forces between two magnets, or you might have seen a magnet and some magnetic substances, like here you can see some paper pins, paper clips are attracted by a magnet, or the nails, they get attracted to a magnet, and here there are two magnets repelling each other from a distance. So you can attract or repel something from a distance when you use a magnet. So then again, a contact is not required, it acts from a distance. So therefore magnetic force is also a non-contact force, right? And then one force we all know about is gravitational force. So because when an apple or any fruit falls down from a tree, it's not in contact with the earth, but still once it ripens or it is plucked, it falls down because the earth attracts objects towards it, and that is known as the force of gravity. So gravitational force also acts from a distance, and hence it is also a non-contact force. So I'm sure it's clear now what are contact forces and non-contact forces. So when we require a contact between the two bodies to interact, that's a contact force, and when the forces act from a distance, that is a non-contact force. Now, as I told you, force is a vector quantity, so the direction also matters. Now here I have an example where two people are pushing a car. You can see, so one is applying a force of 120 Newton and the other one is applying a force of 50 Newton, but both are acting in a direction towards right. You can see the arrows indicate that both the forces, they're acting towards right. So in that case, the total force acting on the car will be the sum of the two applied forces. So F is going to be F1 plus F2. So that means what is your total force acting on the car in this case? So it's 120 plus 50. So that gives us 170 Newton. Because both the forces act in the same direction, they will add each other. And here you see that one person is applying a force of 50 Newton towards right, but the other is applying a force of 120 Newton towards left, as the arrow indicates. So now these two forces, they are acting in opposite directions. And since here the two forces are acting in opposite directions, the car will move in the direction of the larger force. So F will be calculated by the difference of the two, because the direction is opposite. So in one direction it is negative, the other is positive. So I get 120 Newton minus 50, that gives me 70 Newton to the right. So a net force of 70 Newton to the right. So this is 50 Newton applied force, and so if this is 50 Newton applied force to the right and 120 to the left, in that case the net force is 70 Newton to the right. So the direction matters. It's a vector quantity. And in this particular case, where they are acting in the opposite directions, your F is equal to F1 minus F2. In case two equally strong people apply the force, that means your F1 is going to be equal to F2, and so the net force you're going to get is F1 minus F1 because they're equal. So you can write as F1, and that is equal to 0. So the body will not move. Right? And from this we understand that if if an object is acted by two or more forces and there is a net non-zero force acting on the object, then the forces are said to be unbalanced, and in that case your object will move, and it will move with a variable velocity, because there is net force acting in one direction which will either increase or decrease its velocity, so it is moving with a variable velocity. But if a net zero force acts, as I just showed you, that if one person pulls the car from one side with a force of 100 Newton and the other pushes it with a force of 100 Newton from the other side, like just a second, like we can see here. So in case this force is also 120 Newton, so in that case the net force is going to be 120 minus 120, and that will be 0. So when we have a zero net force acting on an object, then the forces are said to be balanced, and hence either the object does not move at all or it keeps moving with a constant velocity. Velocity will not change because the net force is not acting on it. So if two forces act along the same direction on a stationary object, they move the object and speed it up. If two forces act on an object along opposite directions, then the object moves in the direction of greater force. If two equal forces act on an object in opposite directions, the object does not move at all or moves with a constant velocity, and net force on it is 0. So if you find this video was helpful, please subscribe, like and share, and follow us at PCMINR.com on Instagram and Facebook. Thank you.